Welcome to this video on moments, a key topic for your GCSE Physics exam. We will cover the turning effect of a force, the principle of moments, and how these concepts apply to the world around you. What is a moment? It is the turning effect of a force. When a force is applied to an object, it can cause it to rotate. Key terms to remember are pivot, force, and distance, which must be measured perpendicular to the force. The pivot is the fixed point around which an object rotates. Like a seesaw, this central support is crucial. Identifying the pivot is always the first step in any moment's calculation. What determines the size of a moment? You can increase it by using a larger force or by increasing the distance from the pivot. Maximize both, and you get a larger turning effect. The formula for a moment is m equals F times d. Remember, moments are measured in Newton-meters. Always ensure your force is in newtons and your distance is in meters before calculating. Why must the distance be perpendicular? Only the component of distance that is perpendicular to the force contributes to the rotation. Always check your geometry carefully in exam question. Let us look at a worked example. A force of 15 newtons is applied 0.4 meters from a bolt. Using our formula, 15 times 0.4 gives us a moment of 6 Newton meters. Moments can be clockwise or anti-clockwise. They are calculated using the same formula, but the direction indicates which way the object will rotate. An object is balanced, or in equilibrium, when the total clockwise moments equal the total anti-clockwise moments. In this state, the turning effects cancel out perfectly. This is known as the principle of moments. For your exam, learn this statement word for word. For a system in equilibrium, the sum of clockwise moments equals the sum of anti-clockwise moments. To apply this principle, follow these steps. Identify the forces and the pivot, compute the moments on each side, then equate and solve for the unknown. In this example, we have a balanced beam. We know the anti-clockwise moment is 60 Newton-meters. By equating this to the clockwise side, we find the unknown force is 20 newtons. Levers are a perfect example of moments in action. They allow us to move heavy loads using smaller forces by increasing the distance from the pivot, also known as the fulcrum. Levers make work easier by multiplying the turning effect. By adjusting the position of the pivot, you can change the mechanical advantage of the system. Door handles are another classic example. By placing them far from the hinges, we create a large perpendicular distance, making it easy to generate the moment needed to open the door. Now let's explore real-world examples, starting with spanners. A spanner uses moments to rotate a bolt, with the bolt acting as the pivot. The longer the handle, the larger the moment for the same force. Scissors, wheelbarrows, and crowbars also rely on moments. In each case, a pivot point allows a force applied at a distance to generate a turning effect that cuts, lifts, or pries. When you need to increase the turning effect, distance is your best friend. Doubling the distance from the pivot, or doubling the force, will both proportionally increase the moment. Remember these key relationships. More force means more moment, more distance means more moment, and for a balanced system, clockwise moments must equal anti-clockwise moments. Units are vital in your physics exam. Moments are measured in Newton meters, force in newtons, and distance in meters. Always check these units before providing your final answer. Avoid common exam mistakes. Use the correct perpendicular distance. Don't forget your units. Be careful with clockwise versus anti-clockwise directions, and perform unit conversions early. When asked to state the principle of moments, ensure you mention that the object is in equilibrium, clockwise moments equal anti-clockwise moments, and both are calculated about the same pivot. Let's try a practice question. If a child weighing 400 newtons sits 1.5 meters from the center of a seesaw, a second child weighing 300 newtons must sit 2 meters away to balance it. Here's another. A mechanic applies 25 newtons to a spanner 0.3 meters from the bolt. The resulting moment is 7.5 Newton meters. Great work if you included the units. For our multi-force example, a 50 Newton force at 0.8 meters equals a 40 Newton meter moment. To balance this with a 40 Newton force, the distance must be 1 meter. Improving your diagram skills is crucial. When sketching moments, always clearly label the pivot, the direction of forces with arrows, and indicate the perpendicular distances used. Levers effectively use the moments formula. By increasing the lever arm, you can move heavy loads with smaller forces, providing mechanical advantage. There are 3 classes of levers. First class levers have the pivot in the middle. Second class have the load in the middle, and third class have the effort in the middle. The human body is a complex lever system. Your elbow acts as a pivot, and your bicep muscle provides the effort to lift objects, demonstrating moments in your own anatomy. Remember, the most common way to increase a turning effect is to increase the distance from the pivot. Use this tip to excel in your exam questions on moments. Let's look at how distance and force scale together. Doubling the distance from the pivot doubles the moment. Similarly, doubling the applied force doubles the moment. Double both, and the moment increases by a factor of 4. Engineers use moments in many designs. In bridge building, they balance forces so the structure remains stable. Tower cranes use counterweights to offset heavy loads, while bicycle handlebars use distance to make steering easier. Here is a quick vocabulary review. A moment is the turning effect of a force in Newton meters. The pivot is the fixed point of rotation. Force is measured in newtons, and distance must be perpendicular to the force. Test your knowledge with these true or false statements. Remember, moments are in Newton meters, distance must be perpendicular, and a longer lever arm always increases the moment. Follow this strategy for exam questions. First, identify the pivot. Second, find all perpendicular distances. Third, calculate each moment individually. And finally, apply the principle of moments to find your missing value. Keep this overview of moments in mind as you study. It captures the essential relationships between force, distance, and the turning effect that you'll need for your assessments. For higher tier questions, you may need to handle multiple forces or interpret diagrams where distances aren't explicitly labeled. Always show you're working clearly and state whether your moments are clockwise or anticlockwise. Master the core formula. Moment equals force times distance. If you need to find the force, divide the moment by the distance. If you need the distance, divide the moment by the force. Use this checklist to track your revision. Ensure you can define a moment, apply the formula, explain perpendicularity, distinguish between rotational directions, and solve equilibrium problems with confidence. You've got this. Moments is a highly logical topic. Just remember the formula, keep your distances perpendicular, and consistently apply the principle of moments to equilibrium questions. Good luck with your studies.